Hi, so this is going to just be a short video walking you through a couple of extra problems, maybe problems that we haven't done in class. The problems can be found here on Colab. If you just go to video 5.3 problems, you can open that up and print it if you'd like so that you can play along with me. Those are the problems that I'll be doing on this video. Here the first question says a study of elite distance runners found that a mean body weight of 63.1 kilograms with a standard deviation of 4.8 kilograms. Maybe you recognize Ken and Nick, some of our elite distance runners from Eastview, graduated and moved on. Assuming the weights are approximately normal, make an accurate sketch of the weight. And so we're just looking for something like this. We would make a normal curve. We would put 63.1 in the middle. We would indicate the spread at 4.8. Remember that spread goes about to where this changes changes slope a little bit, where it starts to flatten out. That's good enough for what we have to do here. I'm going to take that whole thing and I am just, oops, there it is. I'm going to make a copy of it, pull it down here. Next one says, what proportion of these runners has a body weight below 60 kilograms? So I come in here and I mark roughly where 60 kilograms has to go. It does not have to be accurate. The weights that are below 60 kilograms, keep in mind that I've got my weights here. Lower than 60 is going to be in this direction. So this problem really wants you to find that area. How do we find area? We take that 60 kilograms and we change it to a z-score. So we'll go z is equal to 60 minus the mean, 63.1, divided by 4.8, the standard deviation. I calculated that. Please calculate it on your own. Make sure that I'm right. I got a z-score of negative 0.65. That negative 0.65 is a z-score for that mark of 60. I grab my z-chart and I look up negative 0.65, negative 0.6 down here. Find column 5, which is this one, and find where they intersect. Looks like 2578 is the winning number. So I say that area is approximately 0.2578. What proportion? You may leave your answer as a decimal, or if you'd prefer, 25.78%. They're both good answers. All right, let's move on. Next one says, what proportion of these runners has body weights above 70 kilograms? So let's get our picture again. We want to go above 70 kilograms. So here's my kilograms along the bottom. 70 is going to be up here somewhere. And we want these runners. We want to find that area. So I'm going to take that 70, change it to a z-score. So 70 minus 63.1, divide that by 4.8. I ended up with a z-score. Notice I'm labeling this as a z-score, 1.44. Z right here, 1.44. We'll take that, we'll look at our Z chart, look for a 1.44. It's got to be on the positive side. There's 1.4, column 4. So I'm looking right here, 9251. Let's go back and see what that means on our picture. On our picture, that means that this area here is 92.51. That means to get over here above 70 kilograms, I've got to go 1 minus 0.9251 because the area under that curve adds up to 1. So I have 0.0749. That's the proportion. If you prefer to write that as a decimal, or as a percent rate rather, take that, move that over 2 places, 7.49. 0.49%, and we're good. That's my son. Doesn't he look nice? That's Ken. That one was Nick Olkey. He graduated last year. Maybe you recognize him. Last one, I thought I would share with you a percentile problem because a lot of people tend to have issues with those. So it says calculate and interpret the 45th percentile. So draw yourself a little picture, put the mean of 63.1, put your spread in there so you've got your data gathered together. And 45th percentile. That means that there's a weight in here that is heavier than 45% of others. Well, 63.1 is at the 50% mark. 45th is going to be somewhere around here. We want to find the weight that goes right here at where this area is 0.45. That 45th percentile, sometimes written like this, that means that the area to the left is 0.45. That's one where we can use inverse norm on our calculator, and we can put 0.45, put the mean, put the standard deviation, and you can get it that way, or if you prefer, you can grab your Z-chart, look in the body of the chart here, these are areas for a 0.45, and work the Z-score backwards. Most of you have a calculator that has an inverse norm function on it, so I did that on my calculator. I ended up getting approximately 62.5 kilograms. You'll want to make sure that your value is just a little lower than the mean since we're at 45%, not quite up to 50%, not quite up to that mean. Those are some of the basic straightforward problems. Let's take a look at some others. I'm going to clear the writing off here. There we go. How about the Labrador Retriever problems? It says the weights of healthy adult male Labrador Retrievers, approximately normally distributed, with a mean of 77 pounds. So I'm going to write normally distributed, mean of 77, standard deviation of 6. What weights make up the middle 50%? A lot of you have trouble with that middle 50% or middle anything percent. So I'm going to make my curve. I'm going to put 77 pounds in the middle. I'm going to label the standard deviation at 6. Now I'm going to mark off approximately the middle 50% goes something like this. Percent, area, proportion, these are all probability. They're all the same thing as writing area. That area is 50%. That tells me that there's another 50% to go here and here. Split it up amongst those. I've got 25% in each of those tails. That area has to total 1. So what we want to find here is we want to find what number of pounds go in those two positions. Now again, most of you have a calculator with an inverse norm function. If we start off knowing something about area, we can inverse norm that to find the answer. So I would hit inverse norm on my calculator. The first area has 0.25 to the left, so I'll put 0.25. I'll type in my mean, I'll type in my standard deviation. If you want to see that actually on your calculator, here's second, vars, go down to number 3. That's the inverse norm function. I type in 0.25. Here's the comma. 77, comma, 6. Close it up, and you're good. 72.95 pounds. So this weight is approximately, we'll call that 73 pounds. 72.95 rounded. To get this one, to get this other one here, well, let's take a look. What is the area off to the left of that value? That area is 50 plus the 0.25. So that area is a grand total of 75%. So I'm going to type in 0.75 for my area, 77 for my mean, 6 for my standard deviation. And again, I grab my calculator, inverse norm that, go down to number 3, 0.75, 77, 6, there it is, 81.05 pounds. Let's do ourselves a favor and call that about 81 pounds. And we're good. So what weights make up the middle 50%? If your adult male lab is between 73 and 81 pounds, that's the middle 50% of male Labrador retrievers. Well, let's suppose I have a dog, and his name is Brutus. He's a male Labrador retriever. He weighs 90 pounds. He weighs less than what percent of others? Well, let's get a picture as usual. We've got 77 pounds here. We're looking at a standard deviation of 6. My dog is 90 pounds. 90 pounds we know is going to be out here somewhere. 90 goes along the bottom scale where I have the other dog weights. Now let's figure this out. He weighs 90 pounds is less than what percent? This area here is what it's looking for because 90 pounds is less than all those other weights. So I'm trying to find this area. Well, what do? Let's take that 90 pounds, change it to a z-score. So we'll go z equals 90 minus 77 and divide by 6. 90 minus 77 divided by 6 comes to 2.16. That's a z-score for 90 pounds. So let's grab our z-chart, find 2.16 on the z-chart. I've got to bump it down just a smidge. 2.1, column 6, and what am I looking at? I'm looking at 98.46. Let's look and see how that looks in our problem here. 90, what was that? 98.50, I believe is what it said. 98.50. 98.40, 2.16, 2.16, 98.46, sorry, my bad, 98.46. Could that area possibly be 98.46? No, because the area on the chart is the area to the left of 90. This area is 98.46. If that area is 98.46, the area that I'm looking for is 1 minus 98.46. So that area is going to come out to be 1 minus 0.9846, 0154. That area is 0.0154. In percent, that's 1.54%. There are only 1.54% of other male Labrador retrievers heavier than Brutus. So my dog is pretty darn heavy. I hope that made sense to you with the way I did some subtracting there. Here's a different one that's from our more current material talking about central limit theorem. Let's suppose that we take a random sample of 12 of these dogs. So now I've got n equals 12. I still have a population mean of 77, a standard deviation of 6 pounds. I want the probability that the average weight of those 12 dogs, that would be an X bar, is 73 pounds. I'm going to call that 73 pounds or less, if you don't mind. As I draw a picture of this, I've got my dog weights. I expect those 12 labs to average 77 pounds, but this spread is no longer going to be 6. I've got a sample size of 12, so I've got to calculate the mean of those sample weights. So I go 6 pounds divided by square root of 12. 6 pounds divided by square root of 12, I hope I did that right, 1.73 pounds. That's the spread. So now when I say, let's find the likelihood that our sample of 12 averages to be 73 pounds or less, let's find this area. Let's find out how unlikely that is. So I'll take that value and I'll calculate a z-score. So I'll go z equals 73 minus 77, but I'm going to divide by 1.73. When I do that, I end up with a z-score of negative 2.31. If you recall, any z-score outside of 2 standard deviations away from the mean, like this one, is considered unusual. If I grab my z-chart and look up that area, negative 2.31, negative 2.31 is way down here. 2.3 is this row. My area there is 01, 04. So back down here, this area, 0.0104, tells me that the probability of getting 12 dogs to average to 73 pounds happens only in approximately 1% of the samples of size 12. So that's pretty normal for one lab to weigh 73 pounds, but to get 12 of them to average that, far more unusual. Well, I hope this helped. If you have any questions, feel free to ask me. Thanks. Bye.